So question 3.75. I told you that the shaft of an angle drive shown in this image here. So the shafts are acted upon by two couples shown. So this couple here, 8 pounds and 6 here. So now to replace the two couples with a single equivalent couple, specifying its magnitude and the direction of its axis. As you can see here, as you know from this our here, something like this. So this is MY, MZ, and MX. This way, so we know that our M, we can simply write our M as MX plus MY plus MZ. That is the sum of the X component, Y component, and Z component. So, but for this, we're now told to replace these two couples with a single equivalent couple. And if you notice from this diagram, you can see that we have this the first couple here acting on the Y, and we have the other one acting on Z, right? And there's nothing on X. So it means that we already have the Y component, already have the Z component. So we can easily write this out with reference to this formula this way. We can simply write it out as M is equal to for for the X component, you can see 0. So simply write 0I. But if you look at this our Y component, it is 8. But taking a look at our direction, like we said, for moments, empty moments, counterclockwise is always positive. But looking at this our image, we can see that this moment is acting clockwise. So it has to be negative. So I'm going to write this as negative 8. So minus 8j. Then when we look at our z axis also, we can also see that the z is acting clockwise. So our symbol here also has to be negative. So that will be minus 6k. So that is simply our m. But the question tells us that we should specify its magnitude. So we have to find the magnitude of this m. And that's going to be our roots 0 squared plus minus 8 squared plus minus 6 squared. So equating that, we sum it, we should have 64 plus 36. And that will be 10 Newton meter. So I'm also told to specify the direction of its axis. So here we can simply write, there's this formula that we can write out to use as reference. M is equal to M plus alpha I plus M plus beta J plus M plus gamma K. So this can be used as a general formula to find the direction of our axis. So what we are going to do is to compare the vector form of our moments to this general formula. So we can write as M equal to 0I minus 8j minus 6k. So we compare the two formulas, we can simply extract three equations here. So that will be, the first one will be M cos alpha here is equal to 0, and the other one M cos beta is equal to minus 8, and M cos gamma is equal to minus 6. And like we calculated before, we already calculated our M, the magnitude to be 10. We are going to use these values to find our direction. So for the first part, it's going to be 10 cos alpha is equal to 0. and cos alpha will be 0/10. That will be cos alpha is equal to 0. And alpha is cos arc cos 0, which means our alpha will be 90 degrees. So we do the same for the other part. So we 10 cos beta is equal to minus 8. So cos beta is equal to minus 8 over 10. So cos beta is equal to minus 0.8. Then beta is equal to arc cos 0 minus 0.8. Then our beta will give us 143.13 degrees. And same thing for our gamma. So 10 cos gamma is equal to minus 6 cos gamma is equal to minus 6 over 10, and cos gamma is equal to minus 0.6, and gamma will be at cos minus 0.6, which should give us 126.87 degrees. So each of these value is the direction of our axis.